All right, hello everyone. Today we're going to tackle a super important topic for your board exams, and that's finding the mean of grouped data. Trust me, this question almost always shows up, so let's break it down together and make sure you can absolutely nail it.
So picture this. You've just gotten your test scores back, right? And you have this long list of marks for the entire class. How in the world do you figure out the average mark? Well, that's exactly where we're going to start.
Now, before we jump in, let's do a super quick recap. You might remember from class 9 how to find the mean of, a simple list of numbers. Today, we're going to build right on top of that and handle what's called grouped data. And that's exactly what you'll be dealing with in your class 10 exams. Okay, so look at this. We've got the marks for 30 students from a math test. It's just a jumble of numbers, right? Trying to find the average by adding all of these up one by one? I mean, it would take forever. And it's so easy to make a mistake. So what's the smarter way to do this? Well, instead of dealing with every single number, we organize them. We put them into nice, neat groups, and we call these groups class intervals. This little trick makes everything so much easier to handle.
And there we go. See how much cleaner that is? This is called a grouped frequency distribution table. It tells us at a glance how many students scored in a certain range. Like, you can see right away that 2 students scored somewhere between 10 and 25. That number of students column, that's what we call the frequency, and we use the little symbol Fi to represent it.
Okay, but wait a second. How do you do math with a range like 10 to 25? You can't, right? So we need one single number to represent that whole group. And that number has a special name, the class mark, which we call Xi. And finding it is super easy. You just take the average of the 2 ends of the range. You add the upper limit and the lower limit and just divide by 2.
Okay, you ready? Let's dive into our first method for finding the mean. It's called the direct method. And it's exactly what it sounds like. Pretty straightforward. So let's solve this together. You've got this. So we're starting with our basic table, the one with the class intervals and the frequencies. Our very first job is to add a new column and calculate the class mark, that Xi we just talked about, for every single row.
Let's do the first one. For the interval 10 to 25, we do 10 plus 25 divided by 2, and that gives us 17.5. Simple. For the next one, 25 to 40, we do 25 plus 40 divided by 2, and that's 32.5. And we just keep going, doing that same calculation all the way down the table.
All right, now comes the most important step for the direct method. Pay close attention to this. We're going to add one more column, and for this one, we're going to multiply the frequency, Fi, with the class mark Xi for each class.
Let's check out the table. For that first row, we multiply the frequency, which is 2, by the class mark, 17.5. And 2 times 17.5 is 35.0. For the second row, it's 3 times 32.5, which gives us 97.5. Now this is where you want to be really careful with your multiplication as you fill out the rest of the column.
Okay, we are almost there with this method. The last thing we need to do with the table is add everything up. We need the total for 2 columns, the frequency column, Fi, and that new Fi Xi column we just made. You'll see the symbol sigma. It's the Greek letter sigma. It just means find the sum of. So sigma Fi is the sum of all the frequencies, and sigma Fi Xi is the sum of all those products.
And all that work leads us to this, the formula for the direct method. The mean, which we write as x with a little bar on top, you say it x bar, is just the sum of the Fi Xi column divided by the sum of the Fi column. It's that simple.
So now, all we have to do is plug in the numbers from our table. We take our total for Fi Xi, which was 1860, and we divide it by the total for Fi, which was 30. And that gives us 62. And that's it. We found our mean. The average mark for the class is 62. See? Not too bad, right?
Okay, so the direct method is great. It works perfectly. But what if the numbers were huge, like really big numbers for the class marks or frequencies? The multiplications could get really complicated, and it's easy to make a mistake. That's where a smarter, shortcut method comes in. It's called the assumed mean method.
Now this is a really important exam tip. When you're under pressure in an exam hall, doing big, complicated calculations is risky. That's why this assumed mean method is so great. It's designed to make the math way simpler and cut down on the chances of making a silly error.
So how does it work? Well, it's just a few simple steps. The main idea is that we basically guess or assume a mean somewhere from the middle of our data. Then we figure out how far off each class mark is from our guess. We call this the deviation. This little trick lets us work with much smaller, friendlier numbers.
Let's try it with our same problem. First step, we pick an assumed mean, which we call A. It's usually easiest to pick a value from the middle of the xi column. So, let's pick 47.5. Now we make a new column for the deviation, di. We find it by doing xi minus our assumed mean A. So, for the first row, that's 17.5 minus 47.5, which is negative 30. For the second row, 32.5 minus 47.5 is negative 15. And check this out. For the row we picked, 47.5 minus 47.5 is 0. That's a nice little shortcut.
Okay, the next step should feel familiar. We need to find a product. But this time, we multiply our frequency fi by our new deviation column, di. And look at how much easier these multiplications are. We're dealing with numbers like negative 30 and negative 15 instead of 17.5 and 32.5. Once we do that for every row, we just add up that whole column to get sigma fi di.
Now, the formula looks a little different for this method, but it's really smart. The real mean, x bar, is our assumed mean, a, plus a little correction factor. And that correction is just sigma fi di divided by sigma fi. So we're basically taking our initial guess and then adjusting it at the end to get the perfect answer.
So let's plug in our numbers and see what happens. We have our assumed mean, 47.5, plus our sum of fi di, which is 435, divided by the sum of fi, which is 30. So that's 47.5 plus 14.5, which gives us 62. Look at that! The exact same answer we got before, but we did it with way simpler calculations. Pretty cool, right? All right, so now you have two powerful tools in your toolkit to find the mean. Let's do a quick summary and talk about the big question. Which method should you use and when?
This is a great slide to remember for your revision. Here's the simple rule. If the numbers for xi and fi look small and easy to multiply, go ahead and use the direct method. It's fast. But the moment you see big, clunky numbers, switch to the assumed mean method. It's your secret weapon to save time and, more importantly, to stop yourself from making a silly mistake.
So, to wrap things up, let's go over the biggest exam tips. Number 1, see big numbers, immediately think assuming method. It's your friend. Number 2, always double-check your addition when you're finding the totals, the sigmas. It's such an easy place to lose marks. And finally, remember this. As long as you do the steps correctly, both methods will give you the exact same answer. So you can be confident no matter which one you choose.
Fantastic job today, everyone. You've really mastered how to find the mean using two different methods. Now, here's something to think about until next time. We found the average mark, but what if we wanted to find the most common mark, the one that appeared most often? Well, that has a special name. It's called the mode. And that's exactly what we'll explore in our next explainer. Keep up the great work and keep practicing.